Hello, everyone. Welcome to Statistics 8.4b, Normal Distributions. We're going to be jumping into and actually talking about normal distributions, which is the most common continuous probability distribution of a random variable. But before we jump into that, I want to show you this Galton board. This is an example of the normal distribution. Let's play it. So as you can tell, when we turn it over, each of those beads is a, what would you call it? Discrete data. But looking at it, it looks like it's continuous. But each one of those is a separate input. As you can tell, looking at it, the beads have a choice. Are they going to fall left or are they going to fall right? And statistically, when they are dropped in the dead center, they're going to take this shape. And it's not always going to be as accurate as you would want. As you can tell, like right there, hey, part of it's above here, part of it's above there. It's different. Some of the good ones, they have like one bead that is made from a different metal so that it throws in a little random data right there. So this is what normal distribution will look like. So let's go on, all right? Let's go to the 8.4 notes. So the normal distribution, it's going to look like a bell curve. It's going to look like this right here. Right there. Here's this bell shape right there. Now some bells are going to be wider, some bells are going to be taller. It just depends. Next up, the mean, the median, and the mode are all equal. They're all the same number. And where are they? They're going to be right here. Right here. The mode. Where's most of the information? Right here. Most of the data is in the very center. Next up, the curve. The curve approaches, so let's write this down, approaches but never touches the x-axis. All right. Next up. And finally, all of this data underneath the curve, all the data underneath, filling it all in, not just parts that I just scribbled, all of the area, all, the sum of all area under the curve, is 100%. That's just like, hey, that's just like the probability model we had before. The sum of all the outcomes we could have is equal to 100%. All right, let's continue. So now let's jump and teach you about the empirical rule. Now we have the mean of the data right here. This is the mean. And then we have one standard deviation. Let me make sure I get this. So we have one standard deviation above. We have two standard deviations above the mean. And we have three standard deviations above the mean. Now the same thing happens on the other side. Let me write it in. So this is all the data right here. But that's not the empirical rule. That's just, hey, these parts right here are all interesting. These are all like data points. Hey, look, here's the mean right here. And here's the standard deviation above, here's the standard deviation below. But all of the data in between these 2 points right here, so all this data is actually equal to 68%. So if we take the absolute middle portion of a population and we go one standard deviation above, one standard deviation below, it's going to equal 68% of the population. Now, if we go two standard deviations, that's all this data in here. It's the red plus above it. This is going to be equal to 95%. So 95% of the population is within two standard deviations. Now, you might remember from, the previous section when you had to do standard deviation and you're like, why do we need to know this information? Well, it's this right here. Understanding how much of your population is, within a certain amount is important. Like if you're trying to, sell stuff, you want to make sure that you are reaching the best amount of population that you can without, over making something. Let's say you're doing heights and stuff, and you don't want to make a shirt that's 5X's and a shirt that's like extremely small if, only a certain population will wear it. You want to make sure that you get the most bang for your buck. All right, this last one is actually the greatest right here. It's not the greatest, but it's the last of the rules we normally talk about. This is equal to 99.7%. So that's all the data here. In between, not above the curve, below the curve. But there's still standard deviations above this. So if we just take this going this way, and we go this way, going this way, it's actually 30% above and below, but separated half of it, 15, there's still 0.15% above, and there's still 0.15% below of the population. So let's talk about this. Shaq, remember that basketball star who doesn't play basketball anymore? That guy is actually 5 standard deviations above the norm in height. What does that mean? Well, he's so tall that not only is he taller than, 99.85%, there's a standard deviation in between that and himself. All right, let's go on and show you the example I put. So how much is under this curve right here? So if we remember, this was 34 and this was 34 because it's 68. We don't care about that. We don't care. Well, between here and here was 95%, right? Well, how much is this way and how much is this way? Well, if you remember, the percent under the curve is always 100%. What is 100 minus 95? In 3, 2, 1. It's equal to 5. So if we're talking about all the data over here, it's not 5% because we're also including this. This is still 5% of the data that's not there. So it's going to be, we're now going to divide it by 2. So the area under the curve, 2 standard deviations above. So above, the mean plus 2 standard deviations would be 2.5%. So 2.5% of the population is above 2 standard deviations of the population mean. Let's go on. So we can only use this empirical rule and normal distribution like percentages when it actually looks like a normal distribution, a bell curve. If we have this goal scored per player, and we see this right here, if we actually were to graph this, it would kind of look like a skewed drawing. And what does that mean? Well, this data is skewed. There's an error in it. There's something wrong. Or maybe that's just how the data is. And it's okay. So the data can't be approximate with the normal distribution. We can't just be like, all right, 68 of the population is in between here and here, because it doesn't look like a bell. Let's go on. So if we look at it, this is actually a positive skewed. So we write this down. It's a positive. So that's a little throwback to a section or two. Or right skewed. All right, let's go on to the last paragraph, and we'll be done in 3, 2, 1. Last page. All right, let's use the empirical rule to analyze data. So a normal distribution has a mean of 42 and a standard deviation of 6. Well, what we'd want to do is we'd want to draw the bell-shaped curve, and it might look ugly, but we won't tell anybody. So the mean is at 42. So one standard deviation above that would be 48. And then one standard deviation above that would be 54. And then one standard deviation above and above. We probably don't need to go further beyond that, because the percent of the population for that would be so minuscule it wouldn't matter. Unless we want to compare Shaq's height again. So if we were to go the other way, we would have 36, 30, and 24. So now, if we're answering these questions, it says find the range of values that represents the middle 95% of the distribution. Remember, that's the 2 standard deviations. So the mean's right here. So that would be 1, 2, and then 1, 2. So then the range would be, let's type it in. The range that represents the middle 95% between 30 and 54. That's all we need to do. Oh, wait, there's more. There's another question, so let's answer it. What percent of the data will be greater than 36? Well, that's one standard deviation. So if I go back to here, I know that one standard deviation is 68, I think. Yeah, 68. So if in between here is 68, well then what percent will be above 36? Well, I know from here up, let me do a different color. I know from here up is half the data. It's half the data, so 50%. Well, I want to add this part right here. How much is this? Well, then I just go 68 divided by 2, and this is 34. So now I just add 34 plus 50, and I get 84. That's it. So I'd say, hey, 84% of the population is above 36. That's it. Let's go on. So example 6. Use z-values to locate the specific position. Now we're not going to get a lot of this, so it's okay. We'll just jump in and we'll try to answer it to the best of our ability. So the z-value would be, how many standard deviations from the mean. Like, could we say like 1.2, 1.4? How many standard deviations? We can have a continuous data here. It's okay. So here's the formula. The standard score is equal to observed score minus the mean of the sample divided by the standard deviation of the sample. What? All right, well, basically, to figure out how many of the standard deviation it is, we have to take the number that's there, subtracted by the mean of the number, and then divide by the already agreed upon standard deviation and go from there. That's it. So let's do that. So find z if x is 24. So z is equal to 24 minus 19 if the standard deviation is 3.8. Well, if I use a handy dandy calculator, I'll know that 24 minus 19 is 5, and I have 3.8. If I divide 5 by 3.8, I'll figure out how many standard deviations above I am. So I go like this. I go 5 divided by 3.8, and I get 1.31. Let's round up. 6 is equal to the exact standard deviation above. That's it. All right, guys. I'll catch you in class, and I hope you have a wonderful day. Bye.